Good morning. For science today, we are going to be hearing more about sound waves and a little more about compressions. Do y'all remember from yesterday hearing about, like with a rubber band or a guitar string, when it moves, what happens? It bunches together air particles into what are called compressions. And so it's really the movement of particles that causes that sound to happen. So that's why there is no sound in space, because there's not matter there. Whereas in our air, there is matter, there are particles. So we are going to, the particles allow there to be those compressions and sound there. So we're going to continue hearing about waves, sound waves, and hearing a little bit about pitch as well. For those of you who do music or have done like choir, maybe also just in music classes, you hear about certain pitch, which is the highness or lowness of a sound. And also loudness has to do with the volume. How soft or quiet something is called volume. So we're going to get into that. You will have some notes to take. So after we are done going over these pages, you will need to take out your science notebook and take a few notes. Okay, just like yesterday, I'm going to present over to the book so that you can follow along. There's some good visuals. I want you to see it the entire time. Okay, here is a visual very similar to what you saw yesterday, and also what I posted in Brightfinger yesterday. It says the wavelength of a sound wave is the distance between two compressions. Okay, so that is one wavelength, similar to what one wavelength was in light. Okay, but for a wavelength in sound, the peak is where the compression is. So it peaks where all of this air particle is compressed. Sound waves have different characteristics. Sound waves also are affected by what is around them. So sound waves make different sounds. The length of a wave, or wavelength, is one characteristic of a sound wave. Wavelength is the distance from a point on one wave to the same point on the next wave. Once again, going from one compression point to another is one wavelength. Now, frequency is the number of wavelengths that pass a certain point each second. Slow vibrations make waves with low frequencies. Taking out that rubber band again, which is a great way of representing this. Slow vibrations have a low frequency. So if it takes a long time before there's that compression point, there's that long wavelength and a low-pitched sound. So those slow ones are a low pitch. Low frequency, long wavelength, because it's a long distance between these two peaks. Now, quick vibrations, on the other hand, reading from here, quick vibrations make waves with high frequencies. High frequency because they pass through a given point like this green more often. Notice how many times it crosses through the green. 1, 2, 3, 4. Whereas this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a high frequency wave, a short wavelength, and a high-pitched sound. Sorry, it's hard to see that, but high-pitched sound. It says the frequency of a wave gets higher as its wavelength gets shorter. Short wavelength, high-pitched sound, high frequency. We'll be writing examples of that, by the way, so that you can be reminded. Now, going on with pitch. Whoa. We've got a little kitten here, so cute. It makes a high-pitched little squeaky sound when it mews, whereas a lion makes a low-pitched rumbling sound when it roars. Can you hear the difference? You have the sound of a little kitten mew in your head and a giant roar from a lion. Now we hear differences in frequency as differences in pitch. So we can't really hear frequency, but we hear it as pitch. Pitch is how high or low a sound is. Now a kitten mewing makes a high-pitched sound. A lion roaring makes a low-pitched sound. When you sing a song, you sing notes that have many different pitches. Right? If you are singing a song like, my country 'tis of thee. My country 'tis of thee. Our voice goes up and down. That's what makes it a song, is having not just like rhyming words like poetry, but our pitch goes up and down. The pitch of a sound depends on the frequency of the sound wave. High frequency waves make sounds with high pitches. Low frequency waves make sounds with low pitches. Remember that sounds are made by vibrating objects. Some objects vibrate very quickly. Other objects vibrate slowly. Objects that vibrate quickly make high-frequency sound waves. The sounds have a high pitch. Objects that vibrate slowly make low-frequency sound waves. The sounds have a low pitch. Think about an object that vibrates very slowly. Will it make a sound with a low pitch or high pitch? Low pitch. If it vibrates slowly, it's a low pitch because it has that low frequency. We are going to read a little bit more, but let's pause at that point and begin writing some notes. So at the top of your page, you can go ahead and write your header. I'm going to just write science sound. So we'll write about a few different vocabulary terms and then have some pictures of those wavelengths that we were talking about. So let's start with wavelength. The distance from one point to the same point on another wave. So that shows wavelength. That same peak on another wave, the distance between them is wavelength. Now frequency is the number of wavelengths that pass a certain point each second. I don't know if I was clear enough about that part before, but it's for every second. Okay, so using this same example, the frequency is like this middle dotted line. How often does it pass through that middle dotted line? Okay, now for pitch. Pitch is how high or low a sound is. By the way, you are welcome to do these in cursive. I probably should have done that. I just started writing it in print. But for those of you who are having a hard time with cursive still, you can continue doing this part in print. So an example of high pitch would be a kitten. And an example of low pitch would be a lion. Other examples of high pitch, you could say like a flute, whereas a low pitch could be like a drum. Although there are different types of drums that might be high or low. Low pitch could be like a tuba versus a flute. Okay, I think that is all for that part. Oh, actually, let's do an example of that low frequency and high frequency wave. Low frequency wave would look like this. If this is that part that measures frequency versus high frequency. If this is that given point, high frequency might be something like this. And that relates to low pitch, and this relates to high pitch. And that probably, I guess, should have gone over there with frequency, but they both have to do with this. This is low frequency and pitch, high frequency and pitch. Okay, you can write that part if it helps you too. I pause it if you need that for longer, but we're going to move on to some talk about volume now, volume and amplitude. Now, a plane taking off makes a very loud sound with a lot of energy. The sound has a high amplitude. So it takes a lot of energy to make that sound, so it has a high amplitude. Now, sounds can be loud or soft. The loudness of a sound depends on how much energy the sound wave has. Loud sounds have more energy than quieter sounds do. The amount of energy a sound wave has is determined by its amplitude. Now, the amplitude of a sound wave is how tight the compressions are. Think about plucking a guitar string very hard. The string moves a lot. It pushes hard on the air around it. It makes tight compressions with high pressure. Sound waves with tighter compressions have high amplitude. They make louder sounds. You could also think of it takes a lot more energy to really strum it hard. So that has a higher amplitude. It's going further off of that point. As you can see here, it says, well, you probably can't. It's very far away. Sound waves with high amplitude have high energy and high pressure. So it's moving very far off, high energy, high pressure. The higher the amplitude, the louder the sound. This shows you amplitude, how far off that given point. There is a low pressure, low amplitude, soft sound. So if you pluck the string very gently, though, it moves back and forth only a short distance. It does not push the air so hard. It makes loose compressions with lower pressure. Sound waves with looser compressions have low amplitude, and they make quieter sounds. Now, volume is a measure of how loud or soft a sound is. The loud sound made by a jet plane has a high volume. The soft sound made by a person whispering has a low volume. Volume is the amount of sound energy that reaches your ears. The volume of a sound is related to the amplitude of the sound wave. High amplitude sound waves make loud sounds. So I know this might seem like a lot, but it's really saying the same thing. Just like low frequency just means a low pitch. High frequency is a little high pitch. And for this one, A high amplitude is very, very loud, whereas a low amplitude is very, very quiet, small sounds, quiet sounds. Now, loud sounds have a high volume. Low amplitude sound waves make soft sounds. Soft sounds have a low volume. The volume of a sound goes down as you move away from the source of the sound. We measure volume in units called decibels. The decibels go up as the sound gets louder. The sound near a jet engine is about 140 decibels. So that's the loudest one on this little list. Here's a nice chart of the kind of sound and then how many decibels the sound is. Jet engine is the loudest. Whisper is way down here at about 25 or 30 decibels. So the sound of a jackhammer, it says, is loud. It has a high volume. It would be at about, what do you think? Oh, sorry, you can see the numbers at the bottom. I'd say that's about 110. I'd say that's halfway between 100 and 120 decibels. Okay, for that last part, we are not actually going to write any definitions, but we are going to write a chart similar to what we just did, what we just saw with amplitude. Okay. So, and we'll title it Amplitude / volume, since they're related. Okay. Write pressure over here. High amplitude goes up a long ways. That's the amplitude. So this is an example of high amplitude. And this would be an example of low amplitude. Does not go up very much. Notice the frequency is about the same, which means maybe the pitch is the same, but it's not as loud. So this is an example of low amplitude. In parentheses, I'm also going to add for this one, high amplitude means loud, whereas low amplitude means quiet. And we could make this even higher to really show off that high amplitude. Amplitude is how tall that wave is. Notice that difference. Okay, so that would be a loud sound, could be high or low pitch. This is a quiet sound. You know, there can be a low quiet sound or a high quiet sound. And that can be the same for volume or something with a high volume. Could be high or low pitch. Okay, that is all for your science today. So I hope that you guys are enjoying this short little unit. That is all that you'll need to do for science. I will see you later. Have a wonderful rest of your day. Bye.